And now, on another episode of Insomnia Math. One of the basic formula of number theory is Euler's solution to the Basel problem, the question of what the reciprocals of the squares add up to. What is the sum of 1 plus 1/4 plus 1/9, and so on? The sum converges, and converges rather rapidly, to a sum of pi squared over 6, or around 1.64. Unlike the sum of the powers of 2, there isn't a convenient visual proof or simple explanation of why this answer is what it is, which is why it took a mathematician as great as Euler to find a solution. But what crossed my mind was looking at the sum of the reciprocals of squares not as numbers, but as squares. If you were actually arranging squares with areas of 1, 1/4, 1/9, and the like, what does it look like? As you can see, and as expected, the squares with their diminishing sizes fit comfortably into this area of 2, larger than the area of 1.64. Here, I only use the 22 largest squares in the sequence because beyond that, both the resolution of a monitor and my own manual dexterity make it hard to place them. But some basic mathematics let us know that while the area of these squares is finite, their perimeter is potentially infinite. Because the square root of the squares is just the harmonic series, which diverges towards infinity, although very slowly. This means that while our figure with packed squares has a finite perimeter, the proof of this is too long to include in this short video, it is quite possible to find configurations, such as this one, where the squares have an infinite perimeter inside of a finite area. Also, as long as the area provided is larger than 1.64, it is possible to arrange the squares so that they don't touch. None of this is exactly genius-level mathematical thought, and I probably reinvented the wheel in making these conclusions. But for me, it is interesting how much a seemingly abstract question in number theory can be brought down a bit just by doing something as seemingly simple as playing and rearranging shapes. And by looking at these shapes, I have thought of some further ideas, which hopefully I will talk about in a future video.